That a particle of mass 1.2 kg is placed in a rough plane which is inclined at an angle theta to the horizontal, where sine theta is equal to 7 over 25. The particle is kept in equilibrium by a horizontal force of p newtons acting in a vertical plane containing a line of greatest slope. The coefficient of friction between the particle and the plane is 0.15. Find the least possible value of p. Most important information that they've given us is that this entire system is in a state of equilibrium. So what that means is that the forces that are acting upwards must be equal to the forces acting downwards, and the forces acting rightwards must be equal to the forces acting leftwards. So for that we will need to resolve the forces given in this plane. So first let's resolve this p Newton force. Since it is acting in this direction, it means it has a downward and leftward component, and since it is parallel to the line of greatest slope, this angle will be theta, and that makes this p sine theta, and the force acting leftward as p cos theta. This particle's weight also has two components, which is downwards and rightwards. This will also have an angle of theta, and this will become 1.2 times 10 in order to get the weight, which will become 12 cos theta, and the force acting downward will be 12 sine theta. Other than that, they've given us that it is acting on a rough plane, which means that there is a force of friction acting on the object. So we want the least possible value of p. That will be decided by the direction of friction. But we don't know in which direction it is acting, since we don't know whether this particle is going downwards or upwards. The least value of p will be determined by first making the equations which show a state of equilibrium. So what is the first condition? That the forces acting upwards must be equal to the forces acting downwards. That is pretty straightforward. So p sine theta is acting downwards as well as 12 cos theta. So that means that p sine theta plus 12 cos theta is equals to r, which is the normal reaction of particle. So that is one equation. Now we have the second condition, which is that the forces acting leftwards must be equal to the forces acting rightwards. One force that we have is this p cos theta, which is acting upwards, and this 12 sine theta, which is acting downwards. So the first scenario is that the particle moves upwards. In that scenario, friction would move downwards, making p cos theta equals to friction plus 12 sine theta, since they're both acting in the same direction. What is the other scenario? The other scenario is that the particle moves downwards, and in that scenario friction would operate upwards. And if we write that down in the equilibrium, that means that p cos theta plus friction must be equals to 12 sine theta, making p cos theta equal to 12 sine theta minus friction. So now we have to choose between these two equations. What gives us the least value of p? This one does. So now we will use this one and the first equation in order to find the value of p. They have given us the value of sine theta, which is 7 over 25. We can use this information to find out the value of cos theta. So let's say this is a right triangle and this is the angle theta. So sine theta is always equal to the perpendicular over the hypotenuse. So perpendicular must be equal to 7 and the hypotenuse must be equal to 25 for sine theta to equal 7 over 25. So using the Pythagoras theorem, we can find that the base is equal to 24. Now with this we can find out the value of cos theta, which must be the base over the hypotenuse, making cos theta equal to 24 over 25. So now we can use this information and plug it into these equations. In order to simplify these two equations to find the value of p, you will need to find like terms. So one is cos theta and sin theta, the values that we have, so we can simplify those. The other unknown that we have is p, r, and the value of friction. So we need to find out a way to simplify that. So we know that the value of friction is always equals to mu times r, and they have given us the value of the coefficient of friction mu, which is 0.15. That means friction is equals to 0.15 times r, and since this first equation is giving us the value of r, we can substitute it here in place of r, times p sine theta plus 12 cos theta. Now that we have the value of friction in terms of like terms such as p and sine theta and cos theta, we can write it in the second equation. So that will become p cos theta, and over we know that cos theta is 24/25, is equals to 12 sine theta, and sine theta was 7/25, minus friction, and we found out the value of friction to be 0.15 times p sine theta, and incorporating the value of sine theta again, plus 12 cos theta, so 24/25. So now we can simplify this, and so this means p 24/25 is equals to get 3.36 minus, and when we multiply 0.15 to both of these values, we get minus 0.042p minus 1.728. So we can subtract 3.36 from 1.728. We get 1.632 minus 0.042p. Taking this 0.042p to this side, since they are like terms, we get 1.002p is equals to 1.632, and dividing 1.002 on both sides, we get p is equals to 1.628 newtons, and we can round it up to 1.63 newtons. So with that, we have the end of question number 6.